Here's another example of finding out how much of a salt we can dissolve in a solution given its KSP. And this one is a little bit more complicated than the first example, only in that the salt breaks into more moles of ions. So the first thing we always want to do is write out the dissolution or the dissolving equation and then write out the KSP. And this KSP, the solubility product constant expression, has to take into account the coefficients of those two ions, giving us the third power on the concentration of lithium and the first power on the phosphate concentration. And now we just do a little bit of algebra. We're going to let X equal the phosphate concentration. It's easiest that way because the phosphate is raised to the first power. And then if X is that concentration, then 3X is going to be the concentration of lithium ions because there's 3 times as many moles of lithium ions as phosphate. Then we can just rewrite our KSP expression using those variables. X times 3X, and that quantity has to be cubed, is equal to our KSP, 2.37 times 10 to the minus 6th. And now we just do what this algebra tells us to do. 27x to the 4th is that product. And then we can divide by the 27 to get x to the 4th isolated. Now to solve for x when x is raised to the 4th power, we're going to raise both sides of the equation to the 1/4 power. And the way we do that on a calculator is just to enter the number 8.78 times 10 to the minus 8th. On this calculator, it's the caret symbol. To raise that to the power of 1/4, make sure you put the 1/4 in parentheses, and you get x. And now we have our concentrations. The concentration of phosphate is just X, so that's 0.0172. And the concentration of lithium ions will be 3 times that. So we just multiply that by 3. And we have our two concentrations.